managing machine learning projects, I proposed a daily diet meal plan recommendation system for diabetic patients. In the today's demo, I'm going to discuss the AI extension of the same project, focusing on two key areas. The first one is designing an effective user experience for the AI solution, and the second is to ensure privacy and ethical compliance in how the model is used. Um, so this is a task analysis that I performed for the core problem that I'm solving. Is that the diabetic patients often struggle to follow personalized diet plans due to lack of time or limited knowledge or difficulty in accessing the dietitians. So my solution automates meal recommendations using machine learning, personalized based on user health data and preferences. The key tasks are simple: users input or sync of their glucose or activity data, receive daily meal plans, log whether they've followed it, and view their progress. From the task analysis, I found we can simplify the process by keeping daily interaction under 2 minutes, automating data entry via variables, and using visual dashboards, which with smart reminders. Coming to the user experience or the user interaction flow. Um, so here's how a typical user journey looks. There would be a home dashboard that would show the current day's meal plan and glucose summary. On the input screen, data from variables is automatically synced. So the recommendation screen displays personalized meal plans with calorie and nutrition details. After each meal, user needs to provide feedback, whether they ate as planned, or they modified, or they skipped the meal. So that feedback becomes part of a loop, improving future recommendations and helping to retrain the model periodically. Um, the next task is about the design considerations from a user experience point of view. First, we minimize user input. So most of the health data would come directly from devices or sensors. We then integrate feedback loops, the daily inputs from the users that retrain the recommendation model. We focus on transparency. Each recommendation includes a short explanation, like this meal was chosen due to the morning glucose pattern. To communicate uncertainty, the app displays confidence levels or notes where limited data may affect accuracy. And finally, the interface allows weekly corrections. Coming to the privacy considerations, since our app uses sensitive health data, privacy is definitely a top priority. So we'll apply strict protection measures um, like data minimization or full encryption in the transit and at rest, role-based access for healthcare providers, user consent for all the data usage. We also need to comply with the applicable privacy laws. For example, in US, we have the HIPAA, in Europe, the GDPR, and in India, the new Digital Personal Data Protection Act. So these steps will ensure our system respects both user privacy and global legal standards. Coming to the ethical considerations in the AI design, we anticipate potential bias from uneven training data, such as maybe overrepresentation of certain diets or socioeconomic groups. To mitigate this, we collect diverse data across demographics and regions uh, and continuously monitor model performance across user subgroups. We need to align with three goals of ethical AI: fairness, accountability, and transparency. So I've created a model using Python um, in the Google Colab. So let me quickly show this model. So you are seeing here uh, the Python code that I've used prompt engineering, definitely. I'm not a developer, so through prompt engineering, I've generated this Python code. So basically, the first step that you see is a set of libraries that help with data creation, machine learning, and visualization, and also saving the model. Then uh, I'm creating a synthetic data set, right? Basically, this is to generate a mock data with a set of features like the age, gender, BMI, fasting glucose, HbA1c, activity level, the food preference, adherence to previous adherence, and all of these. And then uh, I'm creating a data frame that will uh, store all these features data. And then the step two is to split the data into 80-20 train and test set. And then I'm using the random forest model classifier that will uh, uh, classify the model. So basically using a set of 150 different decision trees. Uh, and then I'm evaluating the model by getting a classification report. And this model is having a test accuracy of about 94.8%. You see, we are classifying the data using the class 0, 1, 2, 3. Just going one step back. So the target variable here is the meal plan category. So based on the labels that are assigned above. So the labels here are 0 for low carb, 1 for balanced, 2 for high fiber, and 3 for Mediterranean. And based on a formula, we calculate the low carb, balanced, high fiber, and Mediterranean scores. Whichever is the highest score will be taken by the label. And here is a plot of a confusion matrix that shows that here you can see the predicted versus actual. 0, 1, 2, 3 are the respected classes. So you can see that 0 and 1 are dark in color, whereas the 2 is slightly lighter and 3 almost negligible, which signifies that uh, the model accurately predicts the low carb and balanced diet, and also in a better way for high fiber. And it is not accurately predicting the mid Mediterranean. Then here is a dictionary category to plan for each class, a suggestion what could be the breakfast, lunch, and the dinner options for each class. Here is a sample that can test our model. And for example, for the set of features here, for the age 63, gender 0, uh, the BMI, the fasting glucose levels, the predicted meal plan category is 1, and which means it is suggesting the different breakfast, lunch, and dinner options. So, and here we are using the job library to save the model.